Yeah, so now let's talk about like something slightly more complicated. Let's talk about more general polygons rather than just triangles. Let's talk about like quadrilaterals, pentagons, hexagons, like polygons that have an arbitrary number of sides. So we know that the sum of the interior angles, the three angles in a triangle, is always 180 degrees. What if we wanted to know like what is the sum of the angles in like a quadrilateral or maybe a pentagon or a hexagon or things like that? Um, so let's first, like, we know that the sum of the angles in a triangle is always going to equal 180 degrees, right? But like, let's say we have like a quadrilateral, how would we find the sum of the angles, some of the four angles in a quadrilateral? Well, like to do that, what we can do is we can split the quadrilateral like in half, or not in half, but like can split it into two triangles, like one triangle here and one triangle here. So notice that the sum of the three angles in the blue triangle, we already know is equal to 180 degrees, right? And we know that the sum of the three angles in the green triangle is also 180 degrees. So if we just do 180 degrees plus 180 degrees, that would give us the total angle sum of angles in the entire quadrilateral, right? Like this first 180 represents the sum of the blue angles, and this second 180 represents the sum of the green angles. So if we were to add them together, we would get the sum of all of the angles in the quadrilateral. So we would just do 180 plus 180, and that's how you get 360. So that just tells us that the sum of the four angles in a quadrilateral is always equal to 360 degrees. And we can generalize this to polygons that have more sides. Just essentially, let's try to find the sum of the angles in an n-sided polygon. So the way to do this, let's say you have like, if n was 10, what would be the sum of the angles in a 10-sided polygon? So in this case, we just want to generalize it for a general value of n. So what we can do is let's look at small cases, right? So with the quadrilateral, we could split it in half to get two triangles. And each triangle had an angle sum measure of 180. So you did 180 times 2. If you have like a 5-sided polygon, like a pentagon, we can divide the pentagon into like three triangles, right? Like one triangle here, one triangle here, one triangle here. And each triangle is going to have the sum of the angles as 180 degrees. So for a pentagon, you would have 180 times 3 in that case. And yeah, so someone private messaged me and said 180 times n minus 2, where n is the number of sides. Yeah, that is correct. So like, if we were to just list out some more things, like for hexagon, right? For hexagon, we can like divide it into 4 triangles, right? So 180 times 4. So you might notice a pattern. When we had a quadrilateral, this has 4 sides, a pentagon has 5 sides, and a hexagon has 6 sides. And we notice if we look at these red numbers, we notice that like 4 and 2, you see that 2 here is 2 less than 4. And if you look at 3 is 2 less than 5. And like here, 4 is 2 less than 6. So in general, if you have like an n-sided polygon, a polygon with n sides, like if you have like an n-sided polygon, then you would have 180 times n minus 2 in general. If you have an n-sided polygon, you can divide it into n minus 2 triangles, as we just saw from our pattern here. So that tells us that like the sum of the angles in a polygon with n sides would just be 180 times n minus 2. And that's definitely a very important result. So you should probably like remember and understand how this formula works, because it'll be like very useful in like different math problems. So yeah.